This is the Chapter 2 whiteboard lecture on divergent plate boundaries. It will cover PowerPoint slides number 16 through 26. In general, with plate movement, all of the lithospheric plates are moving all of the time. The plates interact with each other because of this, and there are three specific ways in which they can be categorized. Plates can move away from each other, which we call divergence. Plates can move toward each other, which we call convergence, and plates can move horizontally past each other, which is called transform motion. The plates themselves interact with each other at their edges, so where two plates are meeting. Edges, margins, and boundaries are all words that we use to refer to those places where two plates meet up. This is a figure from your textbook, which is just a map of the world showing the different types of plate boundaries, which are color-coded. So the large areas of sort of pastel colors are the plates themselves. So for instance, the North American plate here includes all of this. The South American plate here, all of this. And then the plate boundaries are color-coded by the kind of boundaries. So the place where the Pacific plate meets the North American plate, which is right along here, has some green boundaries, some blue boundaries, and some red boundaries, so all different types. We can see that red boundaries are the divergent plate boundaries, blue is convergent, and green is transform. So just to see if you can pick out what we're talking about when we're talking about boundaries versus plates. I have a simple map here of plates and boundaries. So the key over here tells you that the boundaries are either divergent when they're a thick line or convergent when they're a thin line. So how many plates are on the map? So what we want to do is we want to count the large areas that are between the lines because the lines are where two plates meet. So we have 1, 2, 3, and 4 plates. So how many plate boundaries? Then we're just counting the lines. So we have 1, 2, 3 plate boundaries. So we're going to focus in this lecture on the divergent boundaries, and this is a place where two plates are moving away from each other. Most of these boundaries are found in the middle of an ocean. Magma from the mantle moves up to fill in the space that's created when the two plates move apart. So you can see with the white arrows here that the two plates are moving away from each other. And this shows magma moving up here, and then it would erupt at the seafloor and create new ocean crust all along that area between where the two plates are rifting. So as they pull apart, there's some empty space there. Hot mantle rock rises up, partially melts, and creates magma, and that cools and crystallizes and becomes new plate material. Because we have created a new part of the plate, so we're actually making the plates bigger, we call these constructive boundaries. So a divergent boundary that's close to home is the one in the mid-Atlantic Ocean. We call divergent boundaries mid-ocean ridges when they occur in oceans. So here is North America, Africa, and Europe. And here is that boundary that is going through the middle of the ocean, and the plates are moving like this. So the North American plate includes this part of the Atlantic Ocean, and the Europe and African plate include that part of the Atlantic Ocean. This is a relief map, so a map of the oceans with all the water removed, where you can see that boundary. We have basically a line of volcanoes all the way through the Atlantic Ocean, and that is where new plate material is being created. The oceans are getting wider. Sorry, not all the oceans, just this ocean in this case is getting wider because the plates are moving away and new material is forming in the middle. However, divergence does not start in an ocean. An ocean is actually created through divergence. So divergence starts when a continental plate breaks in half. So it starts in the middle of a continent. We take one plate, like this one here, one continental plate, and it begins to break in two. This usually happens because there is some sort of stress from underneath, like this upwelling, hot mantle rock, and that causes tension or these two pieces of the plate to pull apart. As they pull apart, the rocks break and you get large cracks. These cracks form a rift valley. So the first thing we see in divergence before we create an ocean is a continental rift valley. And that's what's shown here in this figure. So you can see how while uplifting up here, this upwarping was the beginning of the process, after a while we end up with a low area or a valley here. And this part of the lithosphere underneath gets a lot thinner than it used to be, as you can see how it is to each side. A good example of a continental rift valley today is the East African Rift. So as you can locate yourself here from this box, we're over in East Africa, and the East African Rift Valley is outlined in red here. You can see that it extends down here. It actually breaks in two right here because this block of rock right here that contains Lake Victoria is very strong, and so the rift actually goes around it and then re-continues down here. So as rifting continues and the two plates move further apart, so it started as one plate, but once it breaks, we have two plates, and we develop ocean crust in the middle of them, and we create a narrow linear sea. So that's the beginning of an ocean. That rift valley has now filled with water and become a new sea. The Red Sea is a good example of this, and this is associated with the rifting that's going on in the East African Rift Valley. So the East African Rift Valley was down here, breaking apart and coming back together. And the Red Sea is right here, where we also have extension, these arrows pulling apart in either direction. So we move from the continental Rift Valley, and as things widen further, and we really have two separate plates now, we move into this, having this narrow sea. Now, the plate boundary, there didn't used to be a plate boundary here because it was one plate, but now the plate boundary is basically here, and we have one plate on this side and a second plate on this side. Continuing divergence just makes that ocean wider, so we keep making new plate material right here at the ridge, and it keeps being moved away from the ridge. Then new material is made again, continues to move away. So we have the one plate over here and the two plates over here, and they keep getting wider and bigger because of this new material that's being made at the plate boundary itself. So this is a summary of that plate divergence, starting off here at the first step with upwarping and the beginnings of cracking the plate apart. The second step, cracking has become more obvious and blocks are dropping down. We're extending the crust, we're making it longer here through these tensional forces that are pulling it apart. And then finally, we actually break that in two, and we end up with two plates moving apart. And then the last stage is what we call a mature ocean, like the Atlantic Ocean, where we have a large ocean in between two plates, but it is still growing because we are still making new plate material at the mid-ocean ridge.